Well, so everybody should learn C and assembly. We'll start with those two, right? Like,
Assembly.
yeah, if you can't code in assembly, you don't know what the computer's doing. You don't understand, like, you don't have to be great in assembly, but you have to code in it. And then, like, you have to appreciate assembly in order to appreciate all the great things C gets you. And then you have to code in C in order to appreciate all the great things Python gets you. So I'll just say assembly, C, and Python. We'll start with those three.
Welcome to my video on learning assembly and what it's like. So first of all, I want to answer the question, why learn assembly? To answer that, I would say you can either learn to scale up, learning more trendy and interesting topics, which could even get you paid more, or you can do the opposite and truly understand what is going on in a computer. I think that with programming, you can sometimes over-engineer things and have an unnecessarily complicated solution to a simple problem. If I learn assembly, then I can figure out why so-and-so might be unnecessary, this and that might not be that necessary, and things like that. One thing I learned from assembly is that I made too many variables, and making variables can actually start to make the program that little bit more big and bloated. I guess nowadays you don't really need to think about variables too much, but it's interesting to see that even making a variable, you're actually putting something in memory. So that's something to think about. Which assembly to learn? I think that learning 6502 assembly is probably the best one to learn. While with x86 assembly, it's not made to be human readable, and therefore it would be more applicable if you wanted to actually make code that you're gonna. With the x86 assembly, you might make programs that you can actually run and use in your day-to-day life. However, the problem with that is that when you're making something with x86, the only real reason to use it is to optimize a certain specific architecture. But then for that little bit of efficiency, you create code that's harder to debug, harder to understand, and so on. C as a programming language is pretty close to assembly in the sense that you make a program in assembly, it might be like a little bit faster than C, but not by a lot. And that's, in general, they're about the same. If you ever, as a hobby, wanted to learn Apple II or the C64, the Commodore 64, 6502 assembly is the one to learn. Yeah. The resources that I used was this website called, I think it's Skilled Rick, and it's a great tutorial on how to use assembly. I'd recommend. I don't think I can make a video as good as the explanation here, so I'd recommend you watch this video. Watch this video. I'd recommend that you read this. He calls it a tiny ebook, so I'd recommend you read this ebook. And however, the code that you make on that website, that comes with the built-in emulator, it won't work actually. It won't work on an Apple II or a C64. I've tried it, it didn't work. You're probably going to have to do some adjustments onto your code if you want to actually make it run on one of those softwares, one of those computers. So what is learning assembly like? Learning assembly is slow and mentally demanding, as you'd probably expect. However, it is still interesting to think about how people used to code in this and how it's how people still made really good programs with it. I also learned a little bit more about programming that I don't think I would have otherwise have known in a less constricted environment. I really not just learned but internalized that writing clean code is one that is easier to read, and readability really is so important so that you can adjust the code. And I had trouble with that when I made my program, which was to just, it's almost like a hello world program. In fact, I think I should show a time lapse of it, but here is the code anyway. You see, it took a lot of just store. Which one is that? That's, yeah, save. I think of it as a save of whatever's in register A to value to this memory location. It was basically, these are basically pixels on the screen. That looks like a bug, but, and yeah, it was just a lot of trial and error. But if I did something called relative addressing, which I didn't fully understand, it offsets the instruction when everything I'm doing here, I'm offsetting by 1, 1, 1, and then I'm offsetting this by 1, things like that. That would have saved a lot of time. So yeah, thank you for watching. I hope you enjoyed. YouTube is an interesting website because if you what's the word? If you give me a like or write down something in the comments, I actually get paid more, which is really, really cool because you don't have to pay anything, but I do get paid. So it really does help out if you subscribe and do all those things. It just makes the channel, gives the channel more money basically, which is obviously what I would want. So thank you for watching. Take care.